Hey folks, Sega Sonic fan here, and I'm making a quick video to show an interesting, unique kind of repair that I'm doing right now. Sometimes I get people that want me to fix things I've never really looked at before, and in this case, it is a sewing machine control box. This is a sewing machine, I believe, from the 1980s by Mitsubishi. You can see the model number here. I don't know if this is the model number for the machine or the box itself, since I've just been given the box. But I'm going to go ahead and I've been taking a look at it and attempting to build a sort of a fix, repair slash hack to get it working again. This is the guts of the box. And judging from the circuit board made in Japan, looking at the quality of it, it very much looks 1980s or 1990s to me. I believe it's probably 1980s. And this chip right here is obviously the brains of the outfit. It is a D7519HCW-233. I could find nothing as far as information about this chip. So what's the problem? Well, the problem seems to be the case of, surprise, surprise, a leaking old battery. Now, this is actually the new battery. The person that I got this from already replaced the battery. But it had a NiCad, typical 3.6 volt battery. You see these in CPS2 arcade hardware. They were very common in the 80s as backup SRAM batteries because they have kind of a fairly large storage capacity over, say, a CR2032 coin cell battery, something like that. These have a lot more storage capacity, and, you know, they're pretty good overall, but after 20 or 30 years, they leak, they go bad. And in this scenario, what happened was we had a connector here, and that connector went to the display. And the display, well, not really a display, it went to the button interface, I should say. And this is the button interface here, which with different sewing patterns that you can select from. Well, if you look here, we have a bit of a problem, folks. The one of the connectors isn't even there because the leaking battery acid just broke it off. And in addition to that, here's what remains of that. You can see the greenish acid there. And what remains actually got cracked. You see this big line there. That's actually a crack that will totally destroy the conductive property of this flat flex cable. I'm not a fan of these cables. I really hate working on them because you can't solder to them. And it's such a fine conductive material that it takes almost nothing to damage the trace. In fact, this is about 75% plastic, around, you know, less than 25% of actual conductive material. It's a really poor way to reinforce a very important thing. And so what I'm doing is actually creating an alternative. Rather than trying to fix this ridiculous ribbon setup, I'm never going to, of course, get another one of these. Seems unlikely. So what I'm going to do instead is build a tactile push button interface with a standard connector, say something like this, a JST or a Molex. I usually go for JST over Molex since I prefer metric measurements over imperial. Here's the button interface that I'm working on, and how this works out is I'm making it, you know, very carefully to align with all the different buttons. It's not going to be a perfect alignment because the through holes on this perf board is not going to perfectly match up. As you can see here, it's slightly off, especially on the right hand side, but it's going to be within tolerances. You know, we're talking about a millimeter, maybe 1.5 millimeter tolerance, it would seem. And when I put this on, if I might be able to do it with one hand. It's a little hard while I'm holding the camera, but you'll see there, you get your clicks, you get the button separation and everything. So it's not bad at all. In an ideal world, I'll see if I can fabricate some kind of spacer. I don't have access to a workshop right now because of the lockdown, the quarantine in place order, but I'll see what I can rig up here at home. And then, of course, I'm going to drill this out. I'm going to put in my own connector, maybe down here. I've already cleaned off the circuit board here using isopropyl alcohol. And it looks like for the most part, none of these traces have been damaged too bad. There was some leaking acid on D8 and R15, but I got that off. I'm hoping this chip isn't damaged. I'm hoping it'll be okay. These are inputs. They're not outputs, so they should be high impedance connections on the chip, which would mean even if they shorted, hopefully it won't have broken the chip. Given that this chip is somewhat irreplaceable and this control box goes to a, you know, $300 sewing machine, which is going to be used to make masks for people during the COVID outbreak, which is awesome. I'm eager to get this working, and I hope it all works out just fine. So, yeah. If any of you have a sewing machine and a control box, change that battery, folks. Do it carefully. And look out for leaking battery acid and crappy old 80s flat flex ribbon connectors. That's it for this video. This is Sega Sonic Fan, signing out.